Hi, good afternoon and welcome to this Smart Grid Forum's webinar on understanding IEC 62443. My name is Mandana White and I'll be your host for the next hour. So now let's get started with the program. The first session is focused on the essential building blocks of IEC 62443, its benefits and drivers, and the role of grid operators, suppliers, and system integrators in driving its take-up within the power grid. So I'd first like to introduce our speakers. Christian Nerland is the Business Development Director for Cybersecurity at DNV, and Christian will be joined by his colleague Alic Mirnes, who's Cybersecurity Senior Consultant at DNV. So welcome, gentlemen, and I will now bring you up onto the screen.
Yeah, hello, Mandana.
Hi, Christian, welcome.
Thank you.
Right, so over to you.
Hello, everyone. Okay, yeah, so I share this session, as Mandana said, with my colleague Mirnes Alic. So we have 10 minutes in total, so try to cover as much ground as possible. Here is a short listing of the talking points I have. As Mandana said, I'm working in DNV in the unit in Norway within cybersecurity as a business development director. So I'm going to try and give you a little bit of an overview about the threat landscape, what we call holistic cybersecurity, and also the fact that starting early in projects, that's something we see is key and really pays off when you either go ahead with a greenfield or brownfield project. And then also a quick look at some recommended practices that we issued quite recently. So you all seen these type of headlines, not only the last couple of months, but actually increasing over the last years. And the topic of today is accidents that happens to assets, and what we call it that the impact of cybersecurity is getting real. It's real stuff that is affected by the cyber attacks. One prominent example taken from the oil and gas industry is the Colonial Pipeline that happened in the US, where the Colonial Pipeline supplying petroleum products to the east coast of the US was shut down for a number of days. And that was a ransomware attack, and the owner and the operator of the pipeline eventually had to pay almost $5 million to get the flow in the pipe back up and running. So that is one example of many where the impact can be felt by humans, and also other effects as safety related. Cybersecurity for the real world, that's our value proposition to our customers. We focus on the industrial control systems and the OT side of things. We also do IT. But we come to the term real world as it affects real assets and real components. Here is a few examples with a wind turbine and an oil platform. I just wanted to show you quite an interesting piece of research that was done by Gartner. This report was issued back in late January this year. Gartner looked at some 250 companies across all continents and across all industries, basically, just to look at where are these companies on a so-called maturity journey. So if you go from left to right in this figure, it's sort of to the right, it's more cyber mature, and to the left, very immature. And across this population of some 250 companies, Gartner found that actually 60% were in a sort of awareness stage, as they label phase one. Moving on to the right, where companies really are starting to understand the severity, what could really happen to their assets or their operations. They found that 30% are in this stage. And ultimately, on the right-hand side, only 10% are in a sort of an advanced stage, a phase 5, phase 6, where they really start to work systematically and optimize their cybersecurity defense. So I thought I wanted to share that as a quite an interesting background to the topic of today. When we talk about a holistic cybersecurity, it sort of made a very simple sketch here where you put IT on one side and OT on the other side. The topic of today is the 62443 standard, which is underlined at the bottom. dealing with our OT security. As we've already talked about, this is talk about physical assets. We see less frequency, but more severe attacks. Whereas on the other side, we talk about information assets, and you have loss of data, basically. Very frequent attacks, and also less costly when it comes to the financial impact. And then you're dealing with the ISO 27001 standard. At the bottom, the three core pillars of the IEC 62443, the people, the process, and the technology. It's also quite important to note here that, of course, people are using these processes or following the procedures, and it's also people operating the technology. So it's not possible to look at only people or only process. This needs to be looked at as a whole. And we actually, in DNV, we have customers now asking for both certification according to ISO 27001 and IEC 62443, because they want to look at the totality. And as you probably know, there is also a very strong convergence now between the IT and OT side of things. So it's not longer a platform or a grid system that is sort of a standalone that you have to visit to connect to. It's all coming together. And there is a very strong convergence across many industries, actually. Little bit on the topic of actually getting started early on cybersecurity. We have customers that are coming to us very late in their project, where actually is, in some cases, it might be too late to get something properly done. So if you look on, if you imagine that on the towards the right here, the project progress, it could be a new build project, or it could be an upgrade of an installation or something like that. Then your ability to influence, of course, is very high in the early project stages, and also the cost to influence is very low. As you go to the right, the cost is increasing, and the ability to influence is dropping quite significantly. There is a blue figure on the left, which is taken from one of our recommended practices, 0575. And Mirnes, in his presentation, we come back to that a little bit more. But it talks about how you can apply the standard in different project stages throughout. Just to wrap up my little short introduction here, a short overview of the standards that we have issued. There is one first on oil and gas, which is purely based on IEC 62443. And back in August of this year, we also released a recommended practice for cybersecurity and power grid for power grid protection devices. And these are free to download. You just follow the links here, and you can download for free from our webpage. So that was my quick introduction to the topic, and I'll leave it with that and give the floor to Mirnes.
Thank you, everyone, for attending this short presentation. I will give you a short introduction to exposure in power grids, to cybersecurity attacks, how we apply IEC 62443, at least the approach in DNV, and a short case study of a Ukrainian power grid looked through the eyes of IEC 62443. This is an interesting angle to look at this incident from. When we talk about protecting the power and utility chain, and we look at the power grid, we identify a large exposure surface from the generation, transmission, distribution, and then we have your and my houses, retail and consumers, shopping malls, offices. We see that there is a large exposure, a lot of opportunities for attackers to try their tools. And when we look at how we should approach this from a cybersecurity point of view and grow our cybersecurity maturity, we need to look at it from all the Purdue levels. So from the level 0, production, to the business level, at level 4. To apply cybersecurity in utilities and grids, utilities and grid operations, We look, and as we look at the OT, we look at a very diverse landscape. So we have a lot of different technologies, we have a lot of different suppliers and vendors, and we also have a lot of different generations of devices spread across the entire country, region, province. So it is important to include all the technologies in the cybersecurity program. And the main idea here is that every OT part requires its own approach and solutions. If we look at the IT side, we have well-defined standards such as ISO 27001 and that series that is optimized and applies uniformly to all the enterprises, organizations. On the other side, we have an OT side where the OT or ICS community has come together to create a series of chapters or standards that's called the IEC 62443, and they have tried to capture the main concerns and describe controls and barriers and processes, how we can protect our assets in the best way. There are also some other standards that are not very well talked about in the industry, and that is the IEC 62351, that is very useful and very kind of control implementation oriented, that handles protocol and IED devices security. So none of the chapters in IEC 62443 is sector specific. So it is very important and it's very handy to consult the recommended practices that the organizations are creating. To understand IEC 62443 in a better way, a good place to start is to clarify the roles of organizations which are directly affected by the standard. And there we have asset owners, which is typically the end user. We have a system integrator that builds ICS for the asset owner by integrating hardware and software from multiple manufacturers. And then in the end, we have a product manufacturer that designs and creates individual components and systems that the integrator uses later on. That is a good way to start. Then we have requirements and controls. We have IEC that defines an attacker. So who is our attacker? Is it an accident? Is it a low-skill attacker, a moderate, advanced threat that we are trying to defend ourselves from? And based on that, we defined our requirement set. IEC 62443 has many chapters, and they try to cover our entire cybersecurity let's say domain. So from the creating a cybersecurity management system, doing the risk assessments, prescribing how we approach defense in depth to zones and conduits, defining our critical assets, creating a visibility of our networks, and in the end also creating a response to incidents, and also treats to some extent people factor, human factor, and of course supply chain. Applied in the project lifecycle, IEC 62443 has different chapters. So chapter 2.1 and 2.2 talks about early stage specifications, what is important at that stage and who is going to perform those duties. So it describes what obligations has asset owner, what obligations has an integrator, and what obligation has a manufacturer in the end. Here I give an example of, for example, of the design phase, or called here feed phase. So the main responsibility, as always, is on the asset owner, but the work is performed by the integrator contractor that gets input from asset owner and from the manufacturers. And in the end, I would like to discuss a Ukraine power grid attack through the eyes of IEC 62443, where we can see that attack has been performed in 3 steps. There was an email phishing, command and control center was established. We had a second stage enumeration of vulnerable devices, harvesting of the credentials. Towards the end, we had an adversary that tries to be invisible. So they have become the Ukraine grid, and they have cleaned up all the traces. So then they have been waiting for an attack to launch in December 23. And the interesting part is that the whole attack lasted only for 10 minutes with all the effects that it had. So there was a study from IEC or ESA that showed which controls were in place and which controls were missing. And this chart on the right tries to illustrate that. So you can see that in some parts, they had a very good control. They had non-obvious passwords. They had a firewall with strict data flow restrictions. So kind of zones and segregation of the network was in place. They had very good logging and monitoring. We have learned this from kind of incident investigation afterwards. But many other controls were not in place. And the main idea with IEC 62443 is that there's no point in setting up advanced security controls when some basic ones are missing. And in conclusion, in this research, they have said that complying with all the requirements on the security level 2, which means an adversary with low capabilities, would have mitigated the attack and then the consequences of it. Towards the end, we are working a lot with the old stakeholders. We are working with asset owners, integrators, manufacturers as a DNV. We are present in many different sectors, and usually we are involved with the cybersecurity management system, risk assessment, certification and testing of the components on a component level, and training for less known or less publicized standard IEC 62351 as well. So with that, I would like to conclude my speech and give the floor to the next speaker.
Thank you very much, Mirnes. Thank you, Christian, for your introductory presentation. That's really helpful. So I'll ask you to take your seats back in the audience, and we'll call you back up during the Q&A session shortly. Thank you so much.
Thank you.
Okay, so now for our next presentation, which is being delivered by Philip Westbroak, who is the ICS Security Officer at Dutch utility Enexis. And Philip is going to be addressing the issue of applying 62443 in combination with ISO 27001 to fully secure IT/OT converged power grid industrial control and automation systems.
Hello.
Great. Hi, Philip. Welcome. How are you?
I'm fine, thank you.
Excellent. Okay, I'm going to toggle off and I'm going to ask you to share your screen and begin your presentation. Thank you, Philip.
Yeah, no problem. So first of all, thank you, Mandana, for asking me for this seminar. I think it's a very interesting topic. Let me see. You should be able to see my screen right now.
Yes, we can see that. Yeah.
Okay. Excellent. So thanks for inviting me. And I'm indeed, as Mandana said, the security officer for OT at Enexis. We are a regional grid operator with 2.7 million customers approximately. And so we distribute electricity and natural gas. So indeed, the cybersecurity management system, as you see it on the left-hand side here, this is, let's say, the collection of policy documents and work instructions, procedures that together help you in addressing cybersecurity in a structured manner. So looking back at the previous speaker, so if you want to increase your maturity with regard to cybersecurity, this is typically what you do. So move away from addressing security in a very ad hoc fashion, but have a structured approach. And that's the cybersecurity management system. And what we did is also include that or integrate that in our existing quality management system. Because our vision also on cybersecurity is that it should be just one of the quality aspects of all the work that you do, next to, for example, personal safety. So the same should apply to security as well. But of course, this is something that will take quite a lot of time before you reach that level. And this is a continuous process. But indeed, having this kind of PDCA, Plan, Do, Check, Act approach to cybersecurity, that will really help you in increasing your maturity level. And the second example I want to mention is also the risk management process we have. So together with Enexis, the European Network for Cybersecurity, we integrated risk management, so cybersecurity risk management, in our existing risk management approach. So we use bow ties quite extensively. So I think many of you will already know bow ties. It's from the safety, let's say industry, oil and gas. And the reasoning behind this is that you have, let's say, a top event you want to prevent from happening. You have a number of threats that could lead to that top event, and a number of barriers you can implement to prevent that from happening. If that top event does happen, you have some, let's say, barriers to minimize the impact. So that's what we use for all our risk management activities. So all our risk analysis are based on or at least are recorded in bow ties. And we use the standard 62443 standards to also select barriers. So the left-hand side barriers between the threat and top event, we used some examples like these. Social engineering, that's one control you can implement to or awareness trainings, control you can implement to reduce the impact or the possibility of social engineering. Software and information integrity, digital signing of software, all controls that are included in the 3-3 document of the 62443 standard. The same goes for the recovery barriers on the right-hand side in bow ties. So host intrusion detection systems that will help you when, of course, to detect incidents or detect unauthorized traffic in your networks. And the standard will help you in, let's say, identifying that kind of controls. I'll explain in a bit more detail later. Another example, intrusion detection system for networks instead of hosts. So these kind of controls you will find in the 3-3 document. Another example is also to include, let's say, cybersecurity requirements in all the tenders that we publish. So we, of course, do a lot of tenders to procure new equipment in the OT domain. And as from, I think about 8 years ago, we started also to include the formal security requirements in there. Again, also, together with our partner Enexis. And the standard, the 62443 standard, has two documents, for example. So the 4-1, which shows you what kind of security you need to implement during your development processes. So security by design, but also after sales. For example, vulnerability handling. How can you inform your customers about it? So this applies to for example, system integrators, product vendors. And what we also did is includes security requirements specifically for a product or for a component. So the 4-2 document helps you there. So user access management, cryptographic algorithms. So what kind of algorithms should you include? Logging and monitoring. And this is what we now have as a formal part of every tender that we do. So if you look at approximately 2014 and now, what we really see is that security has improved. So looking back at 2014, we had quite a lot of discussions, both internally within my company and also with vendors. So, for example, questions like, do we really need the security, and why do we include it? Because all these devices, all these components are behind firewalls. They are not connected to the internet. That's improved quite a lot. And our expectation is also that since all Enexis members, and there are quite a lot nowadays, European grid operators, other kinds of critical infrastructure, they all use similar requirements. So vendors, they recognize these documents, they recognize the requirements in the tenders. So they also see, well, it adds value to include those controls in their products. So that's, I think, a very good step, a very important step that we made in about 8 years now, 7 to 8 years. And one thing I also really like to show is this slide. So this is a product that we tendered in 2016, I'm not really sure, where we also looked at the security compliance of all the participants in the tender, so all the vendors. On the y-axis, and on the x-axis we looked at the total cost of ownership. And I think this is a very interesting graph, which shows that vendor 1, which eventually won the tender, had 100% compliancy to the cybersecurity requirements we included in the tender, but they also had the lowest TCO. Whereas this one, vendor 12, they had let's say the lowest security compliance and also the highest price. Now, that, of course, that's an outlier, so these are quite near to each other. But the main message of this slide is also that better cybersecurity does not always mean that you have higher costs of your components, which I think is a very good development. And finally, this one, what I want to mention is, let's say, the security baseline we created. So looking at our OT environment, as many of you will know, there's a lot of legacy equipment within OT systems, OT environments. So in our case, protection relays, old protection relays, maybe equipment belonging to transformers, all kinds of examples. And of course, they do not support the latest security controls. They don't have the latest security controls. So we said, well, we want to have a policy about what kind of controls do we need in modern equipment and also in legacy equipment. And that, again, that's where we use the 62443 standard again. So if you look at NXB, I think that's a very good overview of all kinds of controls you can implement. And of course, these controls are explained in more detail in the rest of the Part 3-3 document. But this document, let's say, mentions foundational requirements. So this is one example. The foundational requirement, identification and authentication control. You have 6 others, so use control, system integrity, data confidentiality, all kinds of, let's say, groups of controls you can implement to increase cybersecurity. And looking again at this first one, so identification and authentication control, if you look at that in a bit more detail, you get a lot of detailed controls you can implement, detailed security requirements, and also enhancements that you can use to increase the quality of those controls. And on the right-hand side, the columns, you see the different security levels that the standard identifies. So you have security level 2, the one that Mirnes just mentioned. So this is the security level that you typically select if you want to protect yourself against, let's say, adversaries with limited means or moderate means to, let's say, develop attack functionality. You also have security level 1, 3, and 4. So security level 4, according to the standard, is also, let's say, the security level that you need to protect yourself against nation state-like actors, so secret services. And as you can imagine, typically this is very expensive. So only, very typical industries, typical companies select that security level, or maybe certain devices or zones that apply that need that security level. But the main message here of this table is that based on the security level that you select, based on your own risk assessment, you can see in the standard what kind of controls do I need to implement. So as you can see here, the first one, human user identification and authentication, applies to all security levels. But for example, this one, multi-factor authentication for all networks, only applies to security level 4. Now, the same goes for all the 6 other foundational requirements. And that's what we used also, looking at our security baseline. So we identified this legacy zone with equipment that cannot easily be updated to modern security standards. And also that, let's say, doesn't support the controls that we would typically need. And and those legacy equipment, those legacy zones, of course, for those you need to have compensating security controls. That's where we use the standard as well. Of course, we also have modern zones with equipment which does support the latest security controls and which typically has been procured recently. And there we can, let's say, have the higher security level based also on our own risk assessment and on the tenders that we did previously. Also the controls we need to select for each foundational requirement. So that's the fourth and final example I wanted to mention. So looking forward to the questions that you may have. So that's it for me, Mandana.
Thank you so much, Philip. I'll ask you to take your seat in the audience and we'll call you back up for the questions. So now I'm going to invite onto the screen Antoine D'Hausey. Antoine D'Hausey is OT Security Practice Head for EMEA at Fortinet, and he's going to be addressing the issue of adopting 62443 across a wider range of power grid industrial automation control systems. So, Antoine, welcome. Nice to see you again.
Great pleasure to be your guest again at Smart Grid, and a pleasure to discuss IEC 62443 together with Christian, Mirnes, and Philip. It is a very short presentation, and I will try to convey a few key messages. First, I want to say that compliance to IEC 62443 standard is an ecosystem effort, and this was already mentioned by Christian. It's an ecosystem effort between utilities, system integrators, and product manufacturers. Second is that the standard, they will help us set security targets against specific levels of risks. And this was mentioned already. Actually, I really like Mirnes' example on the Ukraine smart grid bridge, when he stated that back then, or demonstrated that the security level 2 across all security requirements would have been sufficient to avoid compromission of the smart grid. Number 3, it will be important to take into consideration the evolution of the standard. IEC 62443 is not written in stone, and we know that there are various disruptions that are coming into our smart grid environment, starting with the emergence of IoT device that will need specific security measures. So we will talk a little bit about that. But let's start to talk about compliance. So Christian and Philips explained some building blocks of 62443 as well as its role within the broader security management system. IEC 62443 is a list of standards. They were developed by ISA 99, and this figure basically represents the various planned and published work product. As you can see, the standards are regrouped by first component security, then system security, then policies and procedures, and finally general, which includes models, glossary, metrics, and lifecycle aspects. 62443 is a globally recognized standard that is referenced by several other standards and frameworks, such as NERC CIP, NIS and NIS2 directive in Europe, as well as NIS CSF. So this is also very important. Ultimately, utilities will be primarily asked to comply by their national competent authority. However, the implementation of the standard is the responsibility of the security ecosystem. So utilities, system integrators, control vendors, security vendors, regulated body, they will all play a role. Now, how does cybersecurity vendors like Fortinet will support asset owners and system integrators? Well, it will be playing a very important part. If you take the general line, for example, the alignment to 62443-1 terminology and concept is very important in order to work together, because you need to talk 62443 in order to comply to 62443. Now, in policies and procedures, if you take the -2, -5, for example, the security vendor will help define security architecture, secure remote access, account management, malware protection, and many other critical controls. On the system side, the security vendor will need to comply to the -3, -1 requirements, meaning security measures that are tailored to industrial control system. It's going to be needed, and the -3, -3 that is guiding the architecture application to zones and conduits and defense in depth concept. And finally, if we go to the component side, the security and networking solution, just like the other endpoint, they will need to have the right certification for secure development lifecycle and ICS security requirements. But let's get deeper into the standard. So the IEC 62443, it's divided into 7 categories. We touched a little bit on these. These FRs, they are called foundational requirements, or FRs. They expand themselves into system requirements, which are called security requirements and requirements enhancements, the AREs. And now, for each of these security requirements, we want to reach a certain security levels. Again, we touch on these. The security levels, they go from 0 to 4. We see them listed here. They will help the asset owner establish security targets to protect against different level of risk. It goes from casual violation to intentional violation using sophisticated means, these security level 4 that Philippe mentioned before. Now, the third table I'm showing here is mapping the security requirements, or the SRs, as well as the enhancements to the security level. Ultimately, smart grid, just like any other critical infrastructure, they are systems of systems, so that our architects, they will divide these into zones, and the communication paths between them, they are called the conduits. So within the 62443, each security zones and conduits will be assigned a security level target that we can see here. If we are a nuclear power plant, it is quite obvious that the nuclear reactor control unit does not need the same security level than our printing server within our business zone. So these zones and conduits approach with different security level, they are foundational to IEC 62443 standard, and they will represent the right compromise between risk acceptance and the necessary security investments that will be needed across our system. Okay, now the asset owners and the system integrators, they will need to map the security requirements and areas to cybersecurity products and solution. Let me give a few examples. For FR1, you will need good asset and user identification, therefore a role-based access control. For this, we will deploy solutions like certificate authority, domain control, and other tools like two-factor authentication. For the FR5, you will need mainly a good network segmentation. This will be achieved by firewall, switches, access points, and network access control. And some key requirements for this solution will be high availability, performance for SSL encryption, for example, as well as deep packet inspection, including our industrial protocol coverage. For the FR5, for the FR6, so timely response TRE, we will need to have an incident response plan in place with people, process, and technology. And for this last piece, so the technology, we will need to have a SIEM, a system information and event management, or even better, a SOAR, a security orchestration, automation, and response system that will go a step further with automated response functionalities and capabilities to provide log visibility both on the IT and the OT side in order to monitor and report report to the board and report also to the CSIRT as required by the NIST directive. So the list of security requirements and areas within each functional requirement is very long. And as mentioned on the first slide, it is an ecosystem effort. What is important for asset owners and system integrators that are willing to comply to have a quick basically a quick mapping of given solution for a given security level. So this at Fortinet, we did this mapping exercise to support the ecosystem. This is a quick extract, mapping some SRs and areas to Fortinet solution. Basically, the security platform, it's designed to reach security level 4 on each single line item. And at the end of the session, I will provide a link to a white paper that includes a third-party assessment against these security requirements. So this, again, will be useful as a security vendor to be provided to the asset owner and system integrators. Let's move to reference architecture. So we had a look at standard functional requirements and security levels. Let's just represent a smart grid 61850 reference architecture. We will add here the Purdue level to the usual level that we use. It's important because 62443, unlike several standards, it works across all OT sub-industries. It is a cybersecurity standard created by ISA 99, and it's an automation and control security standard. So ISA 99, they use Purdue Enterprise Reference Architecture, or the PERA model, to represent the various levels, so they are important. Purdue level 0 is our smart grid process level with current and voltage sensors and other actuators such as voltage transformer. Level 1 is our Bay level with IDs, so our purpose-built controllers like digital protective relay or phaser measurement units. Level 2 will find our HMIs and our historians, so our engineering and operating workstation, our PI servers to collect our timestamp data. And finally, level 3 is our operation and control zone, or the master station level, whereby we'll find EMS among many other things. This will be the way we map our system when we will need to qualify a security solution on a smart grid reference architecture against IEC 62443. And because IEC 62443 adopted the concept of zones and conduits as well as the Purdue level, I wanted to have this transition slide to get more into the Purdue levels type representation on my next slide, which are showing the evolution of this model. So let's see how we secure across the Purdue level using 62443. The standard specified the security zones and conduits as we discussed before. Above the first dot line is the IT world with your email server ERPs. We have our digital asset in zones, and we shall define secured paths between these zones. These are our enforcement boundaries. They will be enabled mainly by next generation firewall, and this will define our segmentation strategy. The OT side of the house below the red line used to be air gap. This air gap is often, but not always, replaced by the most critical boundary, which is the IT/OT one. It will also create the DMZ below to avoid direct communication between our secure perimeter and the IT world. Now, the Purdue model is evolving with the explosion of IoT and wireless device in the business zone and within the OT secure perimeter. Now, why is this critical? Sorry, I need to go a step back. I'm going too fast here. Why is this critical? Because first, these IoT devices are able to communicate directly to the cloud, so they break the usual zones and conduits model. And in fact, we want to avoid to have on the same network an IIoT or a 5G device with related vulnerability talking to our smart grid critical process without critical control. So let's see how we can do that. This is now showing basically a good segmentation aligned to 62443 that consider the addition of our IIoT and 5G device into OT. As you can see, the IT-OT boundary, it remains unique. So we are able to preserve the OT secure perimeter as well as the unique electronic access point between IT and OT. And this is really a best practice to secure our industrial control system from the business zone. Of course, segmentation is not enough. So we will need other critical control as well as next-gen defense against advanced persistent threats. So let's have a look at this very quickly. So let me give you an example. The IT-OT boundary, DMZ, below will be enabled with a next-gen firewall. Within the DMZ, we'll deploy key security services such as role-based access control, single sign-on, multi-factor authentication with authenticators, endpoint clients, and token solution. Deeper into the process zone will enable further segmentation with industrial class firewalls and switches and access points. The most critical endpoints, such as our engineering and operating workstation, they will be secured with endpoint detection and response solution. IIoT and wireless device, they can be identified, profiled, segmented, and even better, micro-segmented, allowing a more dynamic and secured architecture. Advanced persistent threat measures like sandboxing and honeypotting can also be deployed if you want to reach the security level 4 to face advanced persistent threats and 0-day. So sandboxing, they allow to detonate suspicious file into a contained environment, and honeypot, they will attract bad actors to observe their TTPs, their tactic, technique, and procedures in order to enhance your security measures. So finally, you will have security, central security management, as well as security ratings available in your business zone and at the SOC level. What is important here to emphasize is the alignment of security product and solution to the IEC reference model is very important. We also want to enable this product to speak the industrial protocol language and include all the signatures against OT vulnerability. Okay, so let me wrap it up because I went very fast. I just added a few recommendations to asset owners, system integrators, and control vendors. Sometimes something to take away from this short session. So first, select your partner ecosystem based on your compliance journey. IEC 62443 compliance is far too be trivial. Make sure you work with partners that will support the certification process and follow the standard best practices. Second, make your implementation simple. OT is very complicated, so is cybersecurity. Therefore, you want to make choice based on simplicity, product lifecycle management, and orchestration, as well as integration, because no security vendor have all solutions. So integration, having a security platform that allows the integration is critical. Plan for IIoT and 5G deployments. Think about these when you define your asset management and segmentation strategy. And finally, take the best of OT standards. We talked 62443 today. Take the best practices, use them as a roadmap. I included Sense Institute product white paper. There are here 2 white paper and also a webcast that talks about 62443 standard goes a little bit deeper into that. I encourage you to have a look, because it's also a free asset that can be leveraged on. So many thanks for your attention, and I hope you find this session useful, and I'll hand over to Mandana for Q&A.
Great, thank you, Anton. So we're going to invite the other speakers up onto the screen with us now to take some questions. Right. Okay, we have all of our speakers, so thank you so much for those presentations. Let's start with our first question here, which is a question from Luka Moknik, and he'd like to talk about smart meters. From historical perspective, smart metering is many times part of IT networks. What's your opinion to the idea to put smart meters under OT rules according to standard security levels? And this is for Christian and Mirnes.
Yeah, so this is a good question. The smart meters are an attack vector as well for the OT side, but I would say that they would comply probably with a lot of IT-related security measures, like described by the standards 27001. That there would be a low threshold to include them into the kind of under the OT umbrella, but I don't know how this would reflect on the maintenance and patching and all the other intricacies. Also, if other speakers have some input on that, I would appreciate to hear their opinion as well.
Yeah, I think it's indeed a good question, and it really depends mainly, I think, on the company policy. So if I look at our own situation, we had also smart meters as part of IT until quite recently. So right now they're also part of, we consider them to be part of OT. But of course, that's partly also just a policy decision. But I think looking at also the risk exposure you have with smart meters, they should be considered part of OT.
They are definitely part of our penetration testing engagements always. So
yeah, exactly. Yeah.
I agree with what was said, and in the context of IEC 62443, with what we described today, again the application of zones and definition of security level associated to this zone can help, because here you are in a specific zone. Which type of security level do we want to apply on the various functional requirements specific to this zone is a very interesting exercise. It can be utility specific, geography specific, and I would definitely include this into the OT umbrella on my side.
Okay, great. Thank you all. And we have another question here from Sebastian Schneider at SAEIT. And Sebastian asks, what's the appropriate 62443 SL for an RTU at the different grid power level?
Yeah, also a good question, but I think quite difficult to answer. So if you say, I really want to hear a security level, I would expect, let's say, security level 2. But mainly it depends on your own risk assessment. So where exactly will this RTU be positioned looking at your OT environment? What zone does it serve? And also, what production process is managed? So apparently it's for a grid operator. But yeah, mainly this depends on your own risk assessment.
Okay.
Who is your threat?
Yeah, exactly.
Totally.
Yeah.
Okay, we have a question on certification. So from a 62443 certification perspective, do you see the need coming from a vendor or customer or tenders? Are you proactive versus reactive?
Yeah, that was also a question to me, I noticed. So typically, I think that's security, so increasing security. The main responsibility for that is also from the asset owners. So asset owners should ask for increased cybersecurity. And if they don't do that themselves, also regulators can be of help there. So if only vendors try to push let's call it like that, cybersecurity products, or maybe more increased products with increased security, they run the risk of pricing themselves out of the market. So so I think eventually you should do that together, but I think the first step should also be taken by asset owners and maybe regulators.
Right. Okay, Philip, we have another question that's related here. During procurement of products in a project, do you prefer for product testing, communication security type, etc., in a local laboratory as well before deployment into the network? Do you repeat this testing requirement for each project, even if products are replicated across the projects?
Yeah, so again, it depends on where exactly the product is used. But let's look at the example of a tender. As a part of the tender and to be successfully awarded a certain contract, a successful pen test should be executed. And the same goes for certain projects. So if you have a project with a very, let's say, high risk activity or high risk process, you also should do testing or pen testing in a separate environment. But that also depends on the actual project.
Okay.
Yeah.
And maybe if I can chip in here with my 5 cents, there's also something called like product certification according to this IEC 62443 that is either provided by certified labs or IEC 62443. So that kind of make sure that the same product applied somewhere else has the same security capabilities as
very good point. Very good point. So indeed, ISA Secure provides that kind of service also, or intermediates.
And I believe I will add a third point. I believe also control vendors, when providing standard architectures like unit controls, systems, not systems of system like asset owner, can play a big role providing standard architecture which are 62443 certified then to be leveraged by asset owners. But then, of course, the asset owners have the ultimate responsibility, together with the system integrator, to make it overall compliant. But if you've got pieces of systems that are compliant, then this journey is made easier.
Yeah.
Okay. Another question here. What are the practices that can be adopted for continuous monitoring of vulnerabilities by ICS vendors?
Yeah, sure. So here, typically, you will be in the world of the intrusion detection system. So ICS, IDS, industrial control system, intrusion detection system will play two roles. They will help the asset owner and system integrator perform an asset inventory and also look for threats and map them to your architecture and to your asset. They will also list the vulnerability. So that will be for the detection piece. Now, then you need to take action against this detection. So here you get into more policy management on your network architecture in order to potentially block specific threats, do virtual patching and other types of mitigation.
Okay, Anton, another question for you. Are there in standard any recommendations as how to manage rules and build gateways between different SL?
How to manage rules between different SL?
And build gateways between different SL?
Not quite sure. I understand that question. We need to maybe clarify this thought. You typically would not have rules between security levels, according to 62443.
Right. Okay. Any further thoughts on that from anyone?
Maybe it is referring to different zones, security zones. Where you would have a zone with the critical assets versus a zone that is more exposed. So then how would you define the rules on the gateway between these two security zones?
Okay, so then you would, in this sense, you would do that at the conduits level. So let's not forget that we define zones and conduits, and we assign security levels to the zones and the conduits. So in this sense, yes, you would solve the equation by defining the right security levels with the conduits that goes in between zones.
Yeah, so you typically define trusted and untrusted zone, and then you would say a kind of an obvious example is like a one-way traffic. It's, for example, data acquisition from the external systems for remote viewing or dashboards and so on.
Right, okay. Anton, we have a question for you here related to certification. As I understand it, it's Sebastian Schneider from SAEIT. As I understand it, it's possible to certify a development process according to 62443-4-1, but can you certify a product according to 4-2?
Yes, so you will need to certify to get product that are certified ICS products, so control system family product. Myself, I represent a security vendor, so we have other type of security certification that will be compliant with the IEC 62443-4-1 and -4-2 component certification. I just give an example. If you place a next-gen firewall in IEC 62443 architecture, you will want to check that this next-gen firewall is common criteria certified, and that will enable the or goes above the -4-1 and -4-2 certification. When it comes to a secure development lifecycle, it will be covered by the PCERT team at security vendors that will look for the secure development lifecycle and also provide the right level of certification in accordance to 62443 components requirements.
Okay, great, thank you. And our final question for any of our speakers who'd like to take this on: what is the difference between IEC EE certification versus ISA Secure for 62443? Do you prefer one over the other?
Yeah, I think it depends on who is asking. ISA Secure is the American standard. We have European customers that prefer to have ISA Secure certification. I haven't seen the other way around, but at least that's been the case. But what the difference is, maybe you can pitch in on that, Mirnes.
No. No. Yes.
There's very few companies that have the accreditation in place for ISA Secure. I think it's 3 or something worldwide that has the accreditation. We are working to get it. We'll have sometime early next year, but it's still a limited offering when it comes to certification.
Yeah, that's correct. Yeah.
So that's an opportunity.
Yeah, very well answered.
Yeah.
Okay, great. Well, I think this is a good point in which to wrap up. So thank you to all of our speakers, Anton, Philip, Christian, Mirnes, for all your contributions. It's been a really interesting and in-depth webinar today, and we look forward to seeing you on the platform in a month's time. Last Wednesday of November, we'll be running our webinar on cybersecuring digital substations. Thanks very much. Have a good evening, all. Thank you.
Right.
Thank you.
Bye-bye.
Bye.
Thank you so much for watching. I hope you found this video insightful and enjoyable. We post new smart grid related videos every Friday at 12 CET, so please go ahead and subscribe and let colleagues in other departments and peers in other organizations know so that they can benefit too. We welcome your feedback, so if you have any comments or questions, please feel free to post them below. Thanks again and have a great day.